All right, hi everybody. This is probably going to be a little bit of a rusty video because I haven't made a video in a really long time. But they tend to work for what I need them to, and I think that you'll hopefully be able to follow along and learn a little bit better than you would just by looking at the packets. So we're going to start chapter 13 today, and chapter 13 is about coordinate geometry, which, if you maybe already guessed, means geometry with coordinate points. So we're going to use XY coordinate pairs when we're talking about all of these different things. This chapter should be mainly review for you from Algebra 1. We're just going to sort of take what we learned in Algebra 1 about specifically lines and linear functions and apply it to the constructs of geometry. So apply it to quadrilaterals and triangles and even more lines, but in a more geometrical context. So if I make mistakes in this packet, feel free to point them out to me because that's going to help everybody else learn. I apologize if I do make any mistakes. This video we are going to start by talking about graphing lines. Let me see, I hope that you can see this okay. I wonder if I can zoom in a little bit. Yes, perfect. Okay, so to start, we've got a couple of vocab words, and these are both vocab words that are forms of linear functions. They're both things that you've seen before in Algebra 1. So standard form of a linear function is ax plus by equals c. You didn't use that a whole lot last year, but you have been exposed to it as a form of function. So in the standard form, a and b and c actually don't really stand for anything, but they do have a few rules. We always have to have a be positive. So we'll write a is positive. And the other thing that has to be true about this form is that a and b are both whole numbers. So a and b, and if a and b are whole numbers, c will generally be a whole number as well. So a and b are whole numbers. They don't have to be positive numbers like a does. So b and c can be negative, but they should be whole numbers. And that's something that you can fix while you're putting functions into standard form. Slope-intercept form is what you've already seen. It's your best friend from Algebra 1. That's your y equals mx plus b. We're going to use that a lot this chapter. So y equals mx plus b, and obviously the m is the slope, and the b is the y-intercept. So we're going to start really slow and really easy today. This is stuff that you should be able to do probably with your eyes closed. But I wanted to reintroduce you to it because we're on a bit of a break right now, and I want to make sure that everybody's kept up to the same level. So first of all, we're going to graph from slope-intercept form, so just graphing from y equals mx plus b functions. So you will remember that if you graph a function in y equals mx plus b form, you start with the y-intercept, and you graph that on the y-axis. So our y-intercept is 1, we'll start at 1, and then we'll move the way our slope tells us to. So our slope is 1/2. Remember, our slope is rise over run, so this tells me that to get to the next point, I go up 1 and over 2. So I can go up 1 and over 2 from this point, and continue making some up 1 over 2 dots there. Connect your points together, extend your line all the way to the end of your graphing window, and then make some arrows to show that that line goes on forever. So pretty simple stuff there. Same thing with the next example. In order to graph this, we do need to put it into slope-intercept form. We can't just leave it like y minus 4. We need it to say y equals. But again, easy. Add 4 to both sides. And we get y equals negative 2x plus 4. And then we do the same thing with this one as we did it with the last one. So we're going to start by graphing the y-intercept, which is at positive 4. And then we're going to move that slope. Remember, negative 2 could be the fraction at 2 over 1, so we're going to go down 2 over 1 to get to the next point. So down 2 over 1, and give ourselves some more points there. Connect your points, extend your line in both directions, and put some arrows on the ends to finish that off. Another way we can graph, and this is something you've also seen, but it might be something that you don't remember quite so well because you didn't do it quite so often, is to graph from standard form. And graphing from standard form involves finding the x and y intercept points and using those to kind of denote the graph that you have to make. The way that we're going to find the x and y intercepts in standard form is we are going to use what's called the cover-up method. So cover up method. And you've probably learned this method before. I don't know if you used that name for it, but you definitely talked about it last year when you talked about finding the intercepts of linear functions. So here is a function in standard form, 2x minus 6y equals 6. And we can use the cover-up method to find the x and y intercepts. So to find the x-intercept, we're going to just literally cover up the y term. And if we cover up the y term, we're left with 2x equals 6. So we can write 2x equals 6. We don't need to think about the y term at all. Divide by 2 on both sides, and we get x equals 3, which tells us that our x-intercept point is at 3, or 3, 0, because it's 3 on the x-axis. Our y-intercept point, we can do the same thing. We're going to cover up the x. We're not going to cover up the negative sign in front of the 6y. That's part of the y term, and we need to keep that. So to find the y-intercept, we say, all right, that's going to be negative 6y equals 6. Divide both sides by negative 6. And we get y equals negative 1. So our y-intercept is at negative 1 on the y-axis. You don't need to make more points on these lines. You really only need 2 points to denote any straight line. So once we get our x-intercept and our y-intercept, we can just connect them together, extend our line outward there in both directions, and that is the same thing as graphing the line in slope-intercept form. We just didn't need to change our function into slope-intercept form in order to graph it. Same thing over here, graph 2y plus 3 equals x minus 1. I want to turn this into standard form, and when I look at this, I notice that the x is positive already, and I know that in standard form, I need my x to be positive. So I'm going to move these in a specific way that leaves the x positive. So I'm actually going to move the 2y. So I'll subtract 2y from each side. And I'm going to move this negative 1 over to this side. So I'm going to add 1 also on both sides. So I end up with, let's see, 3 plus 1, so that's 4 equals x minus 2y. Or if you want to, you can switch that, reverse it around so that it looks like a standard form function. Say x minus 2y equals 4. So once you get x minus 2y equals 4, we can just do this as a regular standard form function. I apologize for my cat if you hear her. She's very loud right now. There's not too much I can do about that. So here we're going to use the cover-up method to find the x-intercepts and the y-intercepts. So there's my x-intercept. I'll cover up my y term, and it says x equals 4. That's really easy. So my x-intercept is at 4 on the x-axis. I'm going to do the same thing to find the y, so I'm going to cover up the x term, and it says negative 2y equals 4. I'm going to divide both sides by negative 2, and I get y equals negative 2. So 4 over negative 2 is negative 2. My y-intercept then is at negative 2 on the y-axis. I'm going to take those points, connect them together, and extend my line out to finish that graph. All right, we're going to go here and we are going to convert between the two forms, standard form and slope-intercept form. It is sometimes useful because the standard form can tell you different information than the slope-intercept form can, but also just knowing how to convert between the linear forms of a linear function is an important skill to have. It's pretty easy. You probably could already do this. So to change to standard form, you are going to take a slope-intercept equation. So this one's y equals 8x minus 9. First, we need to think, all right, I need to get the y-intercept, not the y-intercept, I need to get the x term and the y term on the same side of the equal sign. So I'm going to move the x term over here. So I'm going to subtract 8x from both sides. And I get negative 8x equals y. No, sorry, I get negative 8x plus y equals negative 9. And then I'm going to make my x term positive because I need this x term to be positive. So I'm going to write, multiply this whole thing by negative 1. It'll make my x term positive. So then I get positive 8x minus y equals positive 9. And again, it's okay if your y term is negative as long as your x term is positive. We make sure that the x and y are both whole numbers, which they are. So here is the function in standard form. Over here, we've got a slope-intercept form, or a standard form equation that we're going to change into slope-intercept form. So our whole goal is to put this into y equals mx plus b it's pretty easy to do that. We'll move the 7 to the other side. So subtract 7x from both sides. And we get 2y equals negative 7x minus 5. I'm going to put that x term first so it looks like the function that I'm trying to make. And then I'm going to divide both sides by 2. Everything on the right-hand side gets divided by 2. I get y equals negative 7/2. We can leave that as a fraction, or if you wanted to turn it into the decimal, negative 3.5, that's fine. So negative 7/2 x, and again, minus 5/2. If you wanted to turn that into the decimal, 2.5, that's fine as well. And there is your slope-intercept form function. All right, go ahead and turn this over now. Last thing here, pretty simple, horizontal and vertical lines, just to remind you and keep this fresh in your brain. If you have a line that's just horizontal, so no slope, it's just straight across horizontal, that's going to be a line with the equation y equals, and I'm going to write a here, but a is just a placeholder number. Y equals a number is going to be your horizontal line. If you have a vertical line doesn't have a slope, and it also doesn't have a y-intercept. So in order to denote what a vertical line is, we can't use y equals. We can't give it a y value. So we have to make this x equals a number, or x equals a. Here's a couple of examples. They are written in not a form that we know. It's not standard form, and it's not slope-intercept form, but we can turn it into them. So we're going to simplify this. We see there's a 2x on both sides, so we can subtract 2x from each side. And we are going to subtract that off. We get 6 equals negative y. Make sure to bring that negative with you. And then we want a positive y, so multiply both sides by negative 1. And we get negative 6 equals y. So we're going to put that down here as our y-intercept. And it's a horizontal line. It's y equals negative 6, so that's going to go straight across at negative 6. Same thing over here. We're going to turn this one into a graphable form. I see that both sides have a negative 2y on them, so I'm going to add 2y to each side, and it's going to be x equals 6. So that tells me that my x-intercept is 6. And since it's x equals a number, it's a vertical line. It's going to go right through 6 and straight up and down. So like I said, pretty easy stuff, nothing crazy. This is going to be an easy worksheet for you to do. So go ahead and work on the worksheet for section 1 now. All right, have a great day.